चलिए ठीक है, we're all set. ये हम स्टार्ट कर लेते हैं. ठीक है, the paper is on your screen. uh, अच्छा, ये वाला मैंने नहीं सॉल्व किया हुआ. अच्छा, this one you've got the formula of methane is CH4. ठीक है, so there's your formula, and the formula of ethane is C2H6, and you've got which row describes the diffusion and the relative rates of diffusion of methane and CH4. So what's the description of diffusion out of the four?
Particles move from higher concentration to lower.
ठीक है, so it's high concentration to low concentration, या high concentration. It's either A and B. And which one diffuses more quickly, ethane or is it methane? ठीक है, because
Methane.
So it's methane because it has
methane.
lower MR.
Methane. It's methane.
Yeah.
ठीक है, exactly. So light particles जो होते हैं, they travel faster, so it's light, so it's methane. So it's going to be B, I think. Methane diffuses more quickly than ethane. Next one is, which test is used to show that a sample of water is pure? Now, to check that, now remember, it's a question on purity of water, not identification of water. So, how would you know that the water is pure?
It boils at fixed temperature.
ठीक है, so you heat the water. Exactly. So you heat the water to check its boiling point or its melting point. So it's going to be B. Remember, they're two different things. One is identifying water, right? So you have to be careful. Is the question about identifying water? Uske liye the test is cobalt 2 chloride paper. So it's anhydrous cobalt 2 chloride. It changes from pink to blue to pink. Or it might be anhydrous copper sulfate and it changes from white to blue. So that's how you identify water. ठीक है, it's anhydrous cobalt 2 chloride, COCl2, or CuSO4. But this question is not about identifying. Whenever it's about purity of a substance, then it's about the melting point and the boiling point. As the next one, chromatography is used to separate and identify the components in both colored and colorless mixtures. For colorless mixtures, the chromatogram has to be treated with another chemical. So you're doing chromatography and the substances are colorless, which means the spots are going to travel, but you're not able to see them. So what do you add to it?
Locating
agent.
Okay, so it's D, that's your locating agent. And the next one is lithium reacts with fluorine to form a compound. Lithium is in group 1 in the periodic table. Fluorine is in group 7. So is this an ionic compound or a covalent compound?
ionic.
Okay, so it's a metal and a non-metal. So which statement is correct?
Each fluorine atom gains 1 electron.
Okay, so this is going to gain 1 electron to form -1. That would lose 1 electron to form +1. So then there are two isotopes of carbon. Isotopes are substances which have the same proton numbers, same electron numbers, but they have different number of neutrons. So unki atomic mass jo hoti hai, that's different. So which statement about these isotopes is going to be correct? Is one of them more reactive than the other one, or do they have exactly the same chemical properties?
Same
Exactly
chemical.
the same chemical.
Remember, isotopes are always identical. They are exactly the same element, so they behave in exactly the same way. So more reactive, that's...
But the physical properties vary, right?
The physical properties are also kind of exactly the same, except for one thing, which is mass. Because one is heavier and the other one is lighter. So the physical properties are also kind of exactly the same. Like if you make diamond out of carbon 14, you make diamond out of carbon 12, they're both going to be diamonds, except for one of them is going to be slightly heavier. Is that clear?
Yes.
If you make carbon dioxide out of both of them, they're both going to be carbon dioxide, they're both going to be gases, but one of them is going to be slightly heavier. So more reactive, less reactive, that's obviously irrelevant. They have exactly the same reactions. The reactions of this one are similar to this one because they have the same number of outer shell electrons. Is that correct?
Yes.
Okay, because they have exactly the same electronic configuration, the same protons. So this is a hydrazine molecule, and which description of the bonding in hydrazine is not correct? Uh, is it gain or loss of electrons, or is it just
Student bonding.
Sharing
ठीक है
of electrons.
ठीक है. Each nitrogen atom has non-bonding pair of electrons. Is that correct?
Wrong.
How many? So this is. I'm going to draw the uh, structure. It's nitrogen bonded to two hydrogens on one side, and on the other side, it's bonded to a nitrogen. This one is bonded to an H. The number of electrons that they have, they've got nitrogen is sharing a single bond over here, a single bond over here, and it's forming a bond over here as well. This nitrogen is doing exactly the same. So this is the dot and cross diagram of nitrogen, and I'm just showing the bonding electrons. Now, nitrogen has how many electrons? It's in group 5. So how many electrons does it have in total? It's in group 5. So that means it has exactly 3 valence electrons. Sorry, it has exactly 5 valence electrons. Three of them are bonding, so there would be 2 electrons left. And this nitrogen would be exactly the same. The remaining electrons are the non-bonding electrons. So out of the 5, 3 of them are bonding. One over here, one over here, one on this side. 2 would be left. So each nitrogen atom has a non-bonding pair of electrons, and that statement is correct.
Correct.
तो उसने पूछा है not correct का, ठीक है? So that's why that's not going to be the answer. Each nitrogen atom has 4 bonding pairs of electrons. Does it have 4 bonding pairs? One pair over here, one over here.
3.
So it's got 3. ठीक है? Remember bonding pair of electrons. So that's why this one is going to be your right answer. I mean, it's the wrong answer, but that's the one that's going to be correct. Each nitrogen atom shares one of its electrons with a nitrogen atom. That is true. Each nitrogen atom shares 2 of its electrons with hydrogen atom. That's also true. It's sharing one with this and one with this. So that's your dot and cross diagram for N2H4. Next is the next one is that you've got solid X has a high boiling point. Its structure has positive ions surrounded by a sea of electrons. So what does that mean? What structure is that?
Metal.
Metallic.
ठीक है, so that's a metal. That's a metallic bond, and obviously it has a high boiling point. Metals have high boiling points most of the time, except for a few exceptions like mercury. So which other properties, since it is a metal, which other properties would it have?
C.
Okay, so it's going to be
Malleable and electrical conductor.
okay, exactly. The formula of some ions are shown. In which row is the formula not correct? So the charges, etc., are given. Is aluminium oxide? Is this the correct formula?
Yes.
Yeah.
Iron 2 nitride. So which one is nitride over here? This one, this one.
This one, NO3.
Nee, this one.
No.
Remember this. This one is nitrate.
Yeah, it's nitrate.
ठीक है. Remember IDE. ठीक है. Remember this. IDE कौन से वाले होते हैं? IDE is the one जब single element होता है. ठीक है. For example, if you have a single element O with a charge of -2, that's oxide. ठीक है. Cl with a charge of -1, that's chloride. N with a charge of -3, that's nitride. So when you have a single atom, the negative ion is going to be called ide. Well, fluoride, sulfide, sulfur -2, that's sulfide. So remember this IDE. Whenever you see IDE, that means he's only talking about nitrogen. And is the formula correct? Fe has a charge of what? 2 plus? And N has a charge of 3 minus. So is the formula correct?
Wrong.
No, sir.
It's not correct. It's
Yeah,
not correct.
that's
ठीक है,
not correct.
it's going to be Fe3N2, right?
Yes.
So that's the wrong one, not correct. So it's B. Sodium sulfate is fine. Zinc nitrate is also fine. Next one is a moles question. It's saying which volume of gas. So, one second. Anyway, so he's saying which volume of gas produced when 0.1 moles of magnesium nitrate is decomposed. So 0.1 mole is decomposing, and he's talking about the volume of gas. So focus on the gas. So how many moles of NO2 gas would be produced?
4.
If it's not going to be 4, it's going to be, this is 2:4,
2.
right?
2.
So 2:4.
Multiply.
So 0.1 moles, अगर आपके पास होंगे, तो how many moles of NO2 would be produced? That's going to be X, right? And that would give you what?
0.2.
So that's going to give you 0.2 moles. Remember, all moles question, you know the moles of one substance, just use ratios and you can figure out the moles of all the other substances. So anyway, so it's 0.2, and this would be 4:1. So you can use any ratios. You can either use this ratio, it's 2:1, right? So this is 1. So how many moles would this be? Like, you can either use this ratio, 2:1, 0.1:x. What do you get?
0.05.
So you're going to get 0.05 moles. Now, how do you, now he's not talking about the moles, he's talking about the volume of gas that's going to be produced in this. So how do you figure out, how do you convert moles to volume of gas? What do you multiply it by?
24.
Okay. You can either use ratio that 1 mole gas occupies 24 dm cube, or you can just simply multiply it by 24. Multiply both by 24. What do you get?
4.8 decimeter cube.
So this
B
one is
option.
this one is 4.8 decimeter cube. And oxygen would be 24 into 0.05. What is that?
1.2.
So that one is 1.2 dm cube. So remember, he's not talking about a single gas, he's just talking about the total volume of gas. Like, he's not talking about what amount of NO2 gas or what amount of O2 gas. You're going to combine the both of the gases. So it's going to be,
6.
okay, that's going to be your answer in this case. I said next one is, which statement about the electrolysis of molten lead to bromide is correct? Now remember, molten lead to bromide. So let's quickly do electrolysis. You've got cathode and anode. Tell me which one is cathode out of the two, right or left?
Right.
That's your negative cathode. This one is the positive anode. Um, anyone who comes over here is going to gain electrons. Anyone who goes to the other side, that's going to lose electrons. It would get oxidized. So which, as the point is, which two, one second. Anyway, so the point is, lead to bromide, which two ions do you have in your
Lead
solution?
goes to cathode and
PP plus
bromide
2
goes to
and
anode.
Br negative.
ठीक है. So Pb plus 2 gains, you can write the equations. Pb plus 2 would gain 2 electrons, right? And it would form Pb. And Br minus 1 would lose electrons. But remember, group 7 is diatomic, so double it. Okay? It's going to lose 2 electrons. I mean, it's going to lose 2 electrons, just sorry. Not gain. So it would lose 2 electrons, it would form Br2, and 2 electrons would be produced. As anyways, the electrolysis is done. So which statements are correct? The first one, lead ions move to the anode. Is that correct?
No.
Wrong.
Okay, that's obviously wrong. So the first one is wrong. Lead ions move to the cathode and are reduced. Is that correct?
Yes.
Yeah.
Okay, reduction is gain of electrons. Remember that. Bromide ions move to the anode and are oxidized. So that's the opposite, which is also
Correct.
true. And bromide ions move to the cathode. That's obviously wrong.
Wrong.
They don't move to the 2 and 3 are correct. Next one is, copper sulfate is being electrolyzed using carbon electrodes, which are inert electrodes. So you've got again, quickly, you have copper sulfate. This is negative, this is positive. Copper sulfate will have how many ions? Copper 2 plus, SO4 2 minus, and what else?
H positive and OH negative.
Okay, because it's aqueous, so it's going to have H positive and OH minus 1, right? So out of the two, who's going to gain electrons at cathode? And
Cu
The
plus
higher
2 and H
valence
positive.
one.
H positive will gain. Nee, sorry,
No,
Cu
sir,
plus 2.
Cu
It is
will
below
gain
reactivity
less
series.
reactive.
okay, so remember this, the one that's lower in the reactivity series, remember your reactivity series. Copper is right at the bottom, so metallic copper would get deposited over here on and the electrode mass would increase. It's going to become bigger in size. Who's going to lose electrons over here? OH minus 1 or SO4 minus 2?
OH minus 1.
OH negative.
Okay, and the equation is
4OH 2H2O plus O2 plus 4E.
okay, you have to remember this equation. So it's going to lose electrons. So you're going to see bubbles of oxygen gas being formed on this side. There's going to be bubbles forming over here in the solution. Anyway, so which statement? Bubbles of hydrogen are formed at the anode, which is
Wrong.
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 Bubbles of oxygen gas are formed at the cathode, not at the cathode. Okay,
Wrong.
that copper is deposited at the anode.
Wrong.
The blue color of the solution fades.
Correct.
Okay, that's obviously correct, but why does it fade? Because copper sulfate
Oh,
is
yeah.
blue in color. But once the electrolysis is over, the copper ions are gone and the OH ions are gone. So what does the copper sulfate change into? I mean,
H2SO4.
what's left in the solution is H plus 1 and
Sulfuric acid.
so that's
Sulfuric acid is one.
which is colorless. So your blue copper sulfate would fade, and your solution would even would become acidic as well, because an acid is obviously getting formed. This one you have to figure out the enthalpy change of this reaction. Use the table of bond energies. What is the energy change for this reaction? So first thing, you should know how many bonds you're breaking and how many bonds you're forming. So N2, how many N2 has a triple bond. Okay, N2 is very inert because N forms 3 bonds, right? Fluorine forms just 1 bond. So the F2 molecule has just 1 bond, but there are 3 F2 molecules. And they're forming 2 NF3 molecules. N forms 3 bonds. It's in group 5, it forms 3 bonds. And you're forming 2 molecules of NF3, right? I said, now, in this case, how many bonds are you breaking? What's the formula of enthalpy change? Enthalpy change is the amount of energy that's needed to break bonds. That's all positive, that's endothermic. And the energy that's released when you form bonds. So how many bonds have you broken? You've broken the N triple bond N, right? I'm just going to write the values. So what amount of energy is required? That's 950, right? And you've broken the FF bond. That's 150, but you've broken 3 of them, so that's 150 times 3. Is this clear?
Yes.
And on the other side, you've formed how many bonds? You formed 3 NF bonds, right? And they're 2 molecules, so that's a total of 6 NF bonds. So that's 6 into 280, and that's going to be exothermic, right? It's going to be negative. So what do we get?
Minus 280.
So you're going to get minus 280, which will give you B. So now the next one is, which statement about hydrogen fuel cells are correct? So what's the waste product is hydrogen fuel cell is water. So what's the hydrogen fuel cell? In the hydrogen fuel cell, you have a beaker, not a gas jar, and you have, I mean, the shape could be different, and you have another gas jar. There's a hydrogen gas coming in from one side, and there's oxygen gas coming in from the other side, and you have in the gas jar there's platinum catalyst that's added, and there's a bulb outside because there's a current flowing, and the solution has some form of electrolyte, a dilute acid or a dilute alkali. What happens? There's a reaction that happens over here, and that is that O2 reacts with 2H2O, gains 4 electrons, and forms 4 OH ions, right? So that's your reaction that's happening on the left side. The reaction that happens over here is that H2 reacts with 2 OH ions and ends up producing 2 water molecules, I think, and produces 2 electrons, right? So you have to remember all of this. This has to be memorized. This is one side. There's a reaction that's happening on one side, and there's a reaction that's happening on the other side. Is this clear? Do you remember this? So now moving on. The concept of a fuel cell is the reactions are not that important, but the concept of the fuel cell is that there's one side where there's a gain of electrons that's happening. There's a reaction that's happening that gains electrons. And there's another side where the reaction is producing electrons. So electrons are going to be produced from this side and they're going to go to the other side where they're being gained. So there's going to be a constant stream of charged particles. A current would start flowing. Is this clear?
Yes.
Yes, sir.
So the reaction between hydrogen and oxygen is endothermic. It's not endothermic. Why? Because it produces electrical energy. The bulb outside lights up. Is this clear?
Yes.
Okay, so, and remember, all fuel cells are going to operate in this way. I mean, this is just one example of a fuel cell. There are hundreds of different. I mean, like your UPS battery has fuel. It's a fuel cell. When the light goes off, it produces current. What basically happens is there's a reaction that's going on one side which gains electrons, and it could be any reaction, not just this one. It could be any reaction, and there's a reaction that happens on the other side which produces electrons. So the electrons constantly go from the side where they're being produced, and they constantly travel to the side where they're being gained. And there's going to be a constant stream of charged particles, and that's current. I said the waste product in a hydrogen fuel cell is water. Is that correct?
Yes.
Okay, that is correct. Remember, fuel cells, especially the hydrogen oxygen fuel cell, it is pollution free. That's the waste product. Water is produced as a product. Chemical reaction in the cell produces hydrogen, which is used as the fuel.
Wrong.
Hydrogen is the fuel.
Yes.
And that gets used up. There's no hydrogen getting produced, so that's wrong. The hydrogen fuel cell is used to generate electricity, which is obviously correct. So it's going to be 2 and
4.
4. Achha, about the fuel cells, there are 2 advantages and there's 1 disadvantage. What's the 2 advantages?
Water is produced, which is
Pollution free,
yes,
right?
which is
I mean, there is no pollution. There's no harmful products, right? The other advantage is that it's renewable. Okay, that's another one. That hydrogen and oxygen can simply be obtained from the air. That's it. Hydrogen can be obtained from cracking of oil, or you can also obtain it from electrolysis of water. So there are a number of ways to obtain hydrogen. Like metal can react with acids, and that would also release hydrogen gas, right? So lots of places where hydrogen is a renewable material substance. It's present in a lot of places. So it's renewable, and your hydrocarbon fuels or fossil fuels, they get used up, and once they get used up, they're gone forever because it takes billions of years for them to be converted back into fossil fuels. So what's the disadvantage of this? There are 2 disadvantages. Query, the 2 disadvantages. One is that it's very expensive, and although that's not no longer that true, but they're still expensive. And the other disadvantage is that these 2 are gases, so it's very hard to actually store gases. Like gases have to be compressed. They have to be stored at high pressures, which is kind of dangerous. So those are the 2 disadvantages. Is this clear?
yes.
That's the next one. What change is a physical change, not a chemical reaction? Copper to carbonate changes color from green to black when it is heated and stays black when it cools. What's happening here? What's happening to copper carbonate? Remember, you need to know the color of this substance. It's green in color. So why does it change to black?
It converts into copper oxide.
Okay, when you heat it, it decomposes, and copper oxide is the one that's black in color. So there's a chemical reaction happening. That's not a physical change. Ethanol reacts with oxygen to form carbon dioxide and water. Is that a chemical reaction?
Yes.
That's obviously hydrogen peroxide decomposes into that's also a chemical reaction. Ice forms liquid water when it is heated. That's not a chemical reaction. It's just a change of state, a physical change of state. So water solid changes into water that's liquid. Both are H2Os. So nothing happens. There's no chemical reaction that's taking place. I said next one, a student adds, this is about rate of reaction. A student adds 10 cm cube or 0.5 mole per dm cube sulfuric acid, and he adds magnesium ribbon to it. And the hydrogen gas is collected and its volume measured every 10 seconds. So there's sulfuric acid, and he's adding Mg to it, and all the gas that he's producing that's collected. And must be using a measuring syringe to collect the gas. So the volume of gas that's being produced is plotted against time. So the hydrogen gas is collected. The experiment is repeated using the same mass of magnesium ribbon with 5 cm cube of 0.5 mole per dm cube. Remember, magnesium ribbon is in excess. So the quantity of magnesium ribbon doesn't really matter. It's already in excess. You've added too much of it. So the quantity of magnesium ribbon doesn't really matter. So he's using the same mass of magnesium ribbon. But what he's done is he's now using 5 cm cube of 0.5 mole per dm cube sulfuric acid added to 5 cm cube of water. So what's going to happen? Would the reaction be slower or would it be faster? I mean, this is the original reaction, the original experiment. First thing, look at the two sulfuric acids. Is there a change of concentration?
No.
I said, what 5 factors affect the rate of reaction?
Temperature, use of
ठीक
catalyst,
ठीक है, temperature. No, not mass. Not mass. Mass would not affect it. It's temperature, it's pressure.
pressure.
Catalyst is one of them. What are the other two? You've got concentration. Like if you change the concentration, then the speed of reaction would be altered. And the last one is surface area. Like powdered would have a faster reaction, right?
Yes.
So that isn't the same thing like mass. If you have a big ball of like the thing, the powder is like it has more surface area, so obviously it would be fast.
नहीं लेकिन not mass. Mass like if you have a I mean that's if you have this particle and if you have the same mass but you have smaller pieces, right?
Yeah.
This one has more surface area, so mass is not the factor. It's basically the surface area of the particles. Okay, so even if you have a bigger mass and if the reaction speed, it's not because of the mass, it's because of the surface area. So you can keep the mass constant, you can have more smaller particles, but if the surface area is different, then obviously the reaction would be faster. Anyway, so there's nothing mentioned about temperature. He's saying everything is the same. So there's no pressure. There's nothing. The only thing that he's mentioned is concentration, right? The concentration is exactly the same. Is that true?
Yes.
But what would happen if you add 5 cm cube of water to it? Would the
It
concentration
will
change?
become dilute.
It will become more dilute, right? Because if you've added more water, that means less concentrated, right?
Yes.
So that indicates that the reaction number 2, this one over here is going to be a slower reaction, right? Is this clear?
Yes.
ठीक है, is this clear? Do you have any questions about this? ठीक है, by adding 5 cm cube, yes.
So it was like 10 cm cube before, so like that one should be like more dilute.
Nee, but the concentration is, ये मैं explain करता हूँ, just one second. Let me open a board, just one second. Maybe forget this. Uh, Where's the board? Just a second. Okay, let me explain this. Actually, remember in concentration, the volume does not matter. Just one second. You can use this board. Just hold on one second. ठीक है, I'm going to revise that. ठीक है, I'm going to revise the whole rate of reaction. ठीक है. First, concentration. Let's focus on concentration. Now, remember what? As a first thing about concentration. Remember why does the rate of reaction change? पहले तो वो वाला concept. Okay, I have. Remember, when it comes to concentration, the volume is not a factor. Like if the volume is large, if the volume is small. So the volume. So I've got these two beakers. And I have got this one has a smaller volume, this one has a larger volume, right? This one has, let's say it's 5 cm cube, right? And it's got 5 particles. This one is 10 cm cube, and it has 10 particles. So can you tell me, is the concentration the same or not?
Yeah, it's the same.
It's the same, right? So remember, the volume doesn't really matter. The volume could be large, it could be small, it could be less. The volume is not a factor, it's concentration. They have exactly the same concentration. So the number of collisions that they're going to have, it's going to be the same. The number of collisions per unit time, it's going to be the same. So they're going to have the same concentration. That's the first thing. What would increase the number of collisions is that if one of the solution is more concentrated, like you've got 20 particles per unit volume. Now this one is going to have a lot more collisions compared to this one. Is that clear?
Yes.
Yeah.
Okay. Now one of them. So remember this: the volume is not a factor. It could have been the other way around as well. Like this could have been more dilute, right? So this one, because the particles are closer together, they can collide with each other more frequently. This one, the particles are further apart, so they can collide. They're not going to collide with each other that frequently. So just remember, concentration is the number of particles per unit volume. It's in moles. It's N over V, right? C is N over V, number of moles per unit volume. So don't look at volume. Okay, so when you look at this question, the question that we were doing. Ignore the volume. Okay, the volume, I'm going to bring in the volume. The volume is also going to have an effect, but it's not going to have an effect on the rate of reaction. The rate of the reaction is purely determined by concentration, and this one is more dilute, just because you've added water to it. So the concentration is no longer 0.5 mole per dm cube. Instead, it's going to be lesser because you've added water to it. So I'm just going to revise all of it. So you've got concentration. Okay. And remember, concentration only matters for solutions or for gases. Their concentration changes. For solids, it's the particles are always tightly packed. But in solutions, the particles can be far apart from each other. They can be close together, right? So concentration only varies in solutions or in gases. Like you could have a container with more gas particles, so the particles could be very close together, tightly, or there could be less gas in a container and the particles could be far away from each other. That would mean less collisions. Uh, so not remember, this thing would not apply to solids. Is this clear?
Yes.
So then the next one, you've got pressure, right? And remember, pressure only has an effect on the rate of reaction for gases only for gases. If you're If your reactants are gases, only then will this make a difference. Because solids and liquids are not compressible. Like if I have a container and that container has a piston in it, that is a movable piston, what I can do is that the gas particles, they always occupy the whole volume, right? So if I increase pressure, right now the particles are far away from each other, so they have to travel a long distance and then they're going to collide with each other. So it's going to be slower, it's going to take time. But if I increase pressure, if I start compressing it, what's going to happen? If I increase pressure, the particles would
The reaction,
the particles would become
the
closer
rate of
to each
reaction would increase.
would increase. And the reason is that now the particles are closer together. So they're going to bump into each other a lot more. TK, is that clear?
Yes.
So they are closer together. And remember, you have more frequent.
Collisions.
So you're going to get more frequent collisions. TK, and focus on the word frequent collisions. TK, in the first one also, if the particles are like if it's more concentrated, you're going to get more frequent collisions. So in the first one as well, if you have higher concentration, so what do you have? You have more frequent collisions. So focus on the word frequency of collisions. Next one, number 3. What's the third factor? We talked about temperature, right?
Sir,
Yes.
sir, uh, the reaction increases because of the frequent collisions only with the walls of container or also among the particles.
Among the particles as well, ना क्योंकि obviously particles ज़्यादा होंगे तो वो आपस में ज़्यादा टकराएंगे ना नहीं सॉरी इसकी बात कर रहे हो आप
Yes.
नहीं पार्टिकल्स क्लोज टुगेदर हो गए ना तो पार्टिकल्स ऑब्वियसली कंटेनर के साथ भी ज़्यादा टकराएंगे आपस में भी एक दूसरे के साथ दे वुड कोलाइड मोर राइट
Okay.
तो if you increase pressure डिक्रीज करोगे ना तो वो फिर दे वुड बी वेरी फार अवे फ्रॉम ईच अदर लाइक इफ आई डिक्रीज इट तो द प्रॉब्लम वुड बी दैट दे वुड बी वेरी फार अवे फ्रॉम ईच अदर तो उनको बड़ा ज़्यादा ट्रैवल करना पड़ेगा एक दूसरे के साथ हिट करने के लिए ना so which is why they're not going to frequently collide with each other. Is this clear?
Yes.
अच्छा anyways temperature से क्या होता है what happens hmm.
Reaction increases.
तो जो अभी आपने ऊपर
हाँ हाँ
तो जब ये आपने ऊपर कंसंट्रेशन वाला करवाया था जो आपने मुझे 2 एग्जांपल दिए थे कि एक मतलब एक में वॉल्यूम कम करेंगे तो उसकी कंसंट्रेशन पार्टिकल 5 रखेंगे और दूसरे में वॉल्यूम ज्यादा कंसंट्रेशन पार्टिकल आपने 10 रखे तो कंसंट्रेशन तो डिफरेंट हो गई क्योंकि एक में 5 थे एक में 10 थे अगर दोनों में 5 होते तो फिर कंसंट्रेशन सेम होती ना
नहीं concentration होती है number of particles per unit volume ना मैंने इसमें number of particles 10 कर दिए थे ना
जी
राइट यानी ये कितने हो गए 1 2 3 4 5 6 7 8 9 10 अब बताओ कितने पार्टिकल्स हमारे पास 10 पार्टिकल्स और वॉल्यूम कितना है हमारा दैट्स आल्सो 10 cm क्यूब ठीक है तो मुझे बताओ पर यूनिट वॉल्यूम मेरे पास कितना आ रहा है 1 पार्टिकल पर cm क्यूब राइट ठीक है अच्छा इसमें क्या है इसके भी मैं 5 कर देता हूँ ठीक है तो 5 particles in 5 cm cube तो number of particles per unit volume कितना हो गया 5 particles in 5 cm cube right तो इसकी भी concentration क्या होगा तो वही तो concentration दोनों की exactly same है ठीक है what the term concentration remember concentration
वो वॉल्यूम भी आपने इधर बढ़ा दिया
हाँ क्योंकि वो मोल्स ओवर वॉल्यूम होता है ना concentration particles बढ़ाओगे वॉल्यूम भी बढ़ाओगे तो ऑब्वियसली आपका ना दोनों अगर बढ़ेंगे तो फिर कॉन्सेंट्रेशन तो वही रहेगी अच्छा रिमेंबर कॉन्सेंट्रेशन का मतलब क्या है मतलब कॉन्सेंट्रेशन का ना वैसे तो पता है कि फॉर्मूला क्या होता है लेकिन कॉन्सेंट्रेशन का मतलब ये होता है कि पार्टिकल्स कितने करीब करीब है एक दूसरे के इफ द पार्टिकल्स मतलब इफ द वॉल्यूम इज स्मॉल एंड द पार्टिकल्स आर लार्ज तो वो सारे एक दूसरे के करीब करीब होंगे ना तो ऑब्वियसली वो एक दूसरे के साथ दे वुड ऑल कोलाइड विद ईच अदर मोर राइट इज दिस क्लियर
Yes.
या सर
तो हाँ, और मतलब अगर तो वॉल्यूम इज नॉट एन इशू, ठीक है, रिमेंबर वॉल्यूम से कोई फर्क
तो
नहीं पड़ता।
आई थॉट कि कंसंट्रेशन अमाउंट को बोलते हैं।
किसको?
तो मुझे लगा था कि कंसंट्रेशन अमाउंट को बोलते हैं, कि मतलब जिसकी अमाउंट ज्यादा की तो
हाँ नहीं,
कंसंट्रेशन ज्यादा
वही
होगी।
एग्जैक्टली, नहीं
तो अभी
वही
आपने
एग्जैक्टली
बता
ना।
दिया मैंने।
हाँ, तो रिमेंबर कि कॉन्सेंट्रेशन एग्जैक्टली है क्या, ठीक है, कि कॉन्सेंट्रेशन इसके कितने पार्टिकल्स ना करीब करीब हैं, ठीक है, अगर वो दूर दूर है तो उसका मतलब है वो डाइल्यूट है, ठीक है, और अगर वो करीब करीब हैं तो वो फिर ज्यादा कॉन्सेंट्रेटेड है, तो वो इसलिए वो ना उनकी अमाउंट पे डिपेंड करता है, कि हो सकता है मेरी अमाउंट बहुत कम है लेकिन मेरा वॉल्यूम उससे भी कम हो, ठीक है, मतलब फॉर एग्जांपल मैं अमाउंट, अब जिस तरह इसकी अमाउंट कम है, ठीक है, 5 पार्टिकल्स हैं, लेकिन अगर मैं इसका वॉल्यूम और भी कम कर दूं तो वो जो 5 पार्टिकल्स होंगे दे वुड ऑल बी वेरी वेरी क्लोज टू ईच अदर, राइट, तो ऑटोमेटिकली
यस
वो ज्यादा कंसंट्रेशन बढ़ जाएगी, ठीक है, वो पार्टिकल्स थोड़ा करीब करीब आ जाएंगे, ठीक है, इज दिस क्लियर?
या सच में।
अच्छा खैर, टेम्परेचर की बात कर लेते हैं, टेम्परेचर पे आ जाते हैं, टेम्परेचर से क्या होता है? अच्छा, टेम्परेचर से मतलब वो प्रेशर से तो चेंज होता था ना कंसंट्रेशन वगैरह, राइट, तो अच्छा, टेम्परेचर सॉलिड्स लिक्विड्स गैसेस सारों पे डिपेंड करता है। अच्छा, टेम्परेचर से क्या होगा? टेम्परेचर से व्हाई डज द रिएक्शन स्पीड अप?
Kinetic energy of the
काइनेटिक एनर्जी
particles
इंक्रीजेस।
increases.
ठीक है, तो पार्टिकल्स की स्पीड ज्यादा हो जाती है, यानी वो जब एक दूसरे के साथ कोलाइड करें तो वो दे वुड ज्यादा frequency of collisions, you have got more kinetic energy, so they travel faster. If they travel faster, they're going to bump into each other more, so there's going to be more frequent collisions, right? लेकिन not just more frequent collisions, मुझे बताओ कि वो आपस में अगर उनकी स्पीड ज्यादा होगी तो वो एक दूसरे से टकराएंगे ना, तो ज्यादा जोर से टकराएंगे, ठीक है, the collisions are going to be more effective, तो you're going to get more successful collisions as well, क्योंकि रिमेंबर जब भी रिएक्शन होता है यू हैव टू ब्रेक द ओल्ड बॉन्ड्स, तो अगर दो पार्टिकल्स आपस में जोर से आकर टकराएंगे तो ऑब्वियसली ओल्ड बॉन्ड्स टूटेंगे और फिर नए न्यू बॉन्ड्स बनेंगे, सो यू गोइंग टू हैव मोर इफेक्टिव कोलिजंस एज वेल और मोर सक्सेसफुल कोलिजंस। इज दिस क्लियर?
Yes.
यस सर।
कि आपके पास तो नॉट जस्ट मतलब एक तो फ्रीक्वेंसी ऑफ कोलिजंस बढ़ रही है, कि पहले आपके पास यू वर जस्ट हैविंग 100 कोलिजंस, नाउ अगर आपने टेम्परेचर बढ़ाया ना, और ये याद रखना, याद रखने की जरूरत नहीं है, 10 डिग्री सेंटीग्रेड बढ़ाओ ना तो नंबर ऑफ कोलिजंस डबल हो जाती हैं, तो नाउ यू हैव इंक्रीज टेम्परेचर एंड द कोलिजंस हैव इंक्रीज टू 200, ठीक है, तो लेकिन इट्स नॉट जस्ट द कोलिजंस दैट आर इंक्रीजिंग, द इफेक्टिवनेस ऑफ द कोलिजंस आर ऑल्सो इंक्रीजिंग, कि 100 में से ना सिर्फ 10 में रिएक्शन हो रहा था, यानी वो आपस में ना एक दूसरे से इतना आराम आराम से टकरा रहे थे कि रिएक्शन ही नहीं हो रहा था, लेकिन नाउ बिकॉज दे आर मोर एनर्जेटिक, they've got more kinetic energy, now when they collide with each other तो they're going to collide with each other with a lot more force, तो अब अगर 100 कोलिजन्स होंगी ना तो 100 में से ना 90 के अंदर रिएक्शन हो जाएगा, ठीक है, जिसको हम एक्टिवेशन एनर्जी भी कहते हैं, कि the particles must collide with each other with enough force so that a reaction happens, ताकि पुराने बॉन्ड्स टूटें और नए बॉन्ड्स बने। इज दिस क्लियर?
Yes.
अच्छा, उसके बाद आ जाता है कैटलिस्ट। व्हाट डज अ कैटलिस्ट डू? हाउ डज दैट स्पीड अप द
स्पीड
रिएक्शन?
ऑफ द
By lowering the activation energy.
अच्छा, so
या
what a catalyst does is that it lowers the activation energy. अच्छा, कैटलिस्ट जो है ना वो रिएक्शन में कुछ भी नहीं करता, फ्रीक्वेंसी ऑफ कोलिजंस रिमेन्स एग्जैक्टली द सेम, ठीक है, मतलब कैटलिस्ट का लगा के बाद लेट्स से पार्टिकल्स है ना, दे कोलाइडिंग विद ईच अदर, कैटलिस्ट डालने के बाद भी ना दे स्टिल कोलाइडिंग विद ईच अदर विद द सेम फोर्स विद द सेम frequency, so the frequency of collisions does not frequency of the collisions does not change, कि लेट्स से आपके पास ना 100 कोलिजन्स हो रही हैं, तो कैटलिस्ट डालने के बाद भी ना you'll still have 100 कोलिजन्स, क्योंकि ना तो you didn't change the temperature, you didn't change the pressure, you didn't do anything, ठीक है, so frequency of collisions remains the same. What a catalyst does is that it lowers the activation energy, it makes it easier for the reaction to happen, तो पहले अगर 100 कोलिजन्स हो रही थी ना उनमें से सिर्फ 10 में रिएक्शन हो रहा था, क्योंकि पुराने बॉन्ड्स ना बहुत स्ट्रांग थे और वो टूट नहीं रहे थे। अब ये होगा कि अभी भी 100 कोलिजन्स ही होंगी, लेकिन अब पुराने बॉन्ड्स जो है ना कैटलिस्ट ने किसी तरह उनको तोड़ना आसान कर दिया, ठीक है, तो अब रिएक्शन जो है ना बड़े आराम से हो रहा है, सो यू गेट मोर इफेक्टिव कोलिजन्स,
कैटलिस्ट रिएक्शन स्टार्ट तो नहीं कर सकता ना?
मैं वैसे एक आइडिया देता हूँ व्हाट डज अ कैटलिस्ट डू. मतलब फॉर एग्जांपल यू हैव दिस रिएक्शन Haber process, right? N triple bond Na, right? And you've got an H2 molecule and they react together to form uh, N2 molecule, 3 H2 molecules, and they react together to form two
Ammonia.
molecule ammonia, right? अच्छा मुझे बताओ कि this reaction has a very low yield. बड़ी मुश्किल से ये reaction होता है. Can you explain कि what's the problem? H2 और N2 आपस में क्यों नहीं react करते? Why does the reaction happen so slowly?
They have strong covalent bonds.
ठीक है, the N2 और remember air के अंदर ना N2 होता है 78% of air is N2. It's got very strong bonds, right? So the problem is कि even if they collide, ठीक है, ये N2 जाके ना H2 के साथ कोलाइड कर रहा है, राइट? रिएक्शन नहीं होता. मतलब यू गेट 100 कोलिजन्स बट नो रिएक्शन हैपेंस क्योंकि N2 का बॉन्ड ही नहीं टूटता. डू यू गेट माय पॉइंट? इज दिस क्लियर?
Yes.
अच्छा, अब व्हेन यू ऐड अ कैटलिस्ट क्या करता है? इस केस में कौन सा कैटलिस्ट होता है हेबर प्रोसेस में? डू यू रिमेंबर दैट?
Iron.
वनेडियम
नहीं, आयरन होता है. हेबर प्रोसेस में आयरन होता है, कॉन्ट्रैक्ट प्रोसेस में वनेडियम पेंटाऑक्साइड. सो व्हेन यू ऐड आयरन, आयरन क्या करता है? आयरन मेक्स द ट्रिपल बॉन्ड ओवर हियर वेरी वीक. तो इसलिए ना ये जब कोलिजन्स होती है ना, ये बॉन्ड बड़े आराम से टूट जाता है. आयरन खुद रिएक्शन के अंदर पार्टिसिपेट नहीं करता, बट व्हाट आयरन डज इज दैट इट समहाउ मेक्स दिस बॉन्ड एक्सट्रीमली वीक. और उसकी वजह से क्या होता है कि कोलिजन्स अभी भी उतनी हो रही हैं, ये दोनों जाके कोलाइड करें, 100 कोलिजन्स हो रही हैं, लेकिन पहले रिएक्शन हो ही नहीं रहा था. ठीक है, वो कोलाइड करते थे लेकिन N2 का बॉन्ड ही नहीं टूटता था. बहुत ही हाई एक्टिवेशन एनर्जी थी, मतलब इनको बहुत जोर से कोलाइड करना पड़ता था तब जाके N2 का बॉन्ड टूटता था. You had to have very high temperatures. But now what has happened is कि by adding a catalyst, the N2 bond has sort of, so उसकी जो bond strength है ना, वो bond weak हो गया by adding the iron catalyst, जिसकी वजह से it breaks very easily. तो collisions अभी भी 100 ही हो रही हैं, but now 80 और 90 के अंदर ना reaction हो जाता है. Is this clear? The idea clear?
Yes.
या तो इससे ये रिड्यूस हो सकता है कि मतलब कैटलिस्ट रिएक्शन को स्टार्ट करते हैं
हाँ, मतलब catalyst provides
या
the,
फिर
it reduces the activation. It doesn't provide energy. It just reduces the activation energy. यानी वो जो start में energy चाहिए थी ना to break the bond, it makes it a lot easier to do that. ठीक है?
अच्छा, बट इट डजंट स्टार्ट द रिएक्शन, राइट? मतलब इट
नहीं,
लोअर्स द
catalyst
एक्टिवेशन
देखो,
एनर्जी ऑब्वियसली.
हाँ, लेकिन catalyst is needed throughout the reaction. Like if uh, but it's I mean you need it throughout the reaction. मतलब collision तो हर वक्त हो रही है ना. मतलब ये मॉलिक्यूल जाएगा फिर कोई और मॉलिक्यूल आ जाएगा N2 का. डू यू गेट माय पॉइंट?
यस.
ठीक है, वो जो स्टार्ट के अंदर आप कह रहे हो ना कि फॉर एग्जांपल यू आर बर्निंग पेपर, राइट? या यू आर बर्निंग अ पीस ऑफ वुड. तो स्टार्ट के अंदर इफ अ रिएक्शन इज एंडोथर्मिक तो उसको शुरू में एनर्जी चाहिए होगी. ठीक है, इट इन द फॉर्म ऑफ एक्टिवेशन एनर्जी. सम एनर्जी वुड बी नीडेड एट द स्टार्ट टू ब्रेक द बॉन्ड. डू यू गेट माय पॉइंट?
यस.
जैसा माचिस को जलाने के लिए यू हैव टू, या पेपर को जलाने के लिए यू हैव टू गिव इट एनर्जी एंड देन इट स्टार्ट्स बर्निंग, राइट? तो वो इनिशियली एनर्जी इसलिए चाहिए होती है बिकॉज यू हैव टू ब्रेक द बॉन्ड्स. क्योंकि अगर पुराने बॉन्ड्स नहीं टूटेंगे ना तो हाउ कैन न्यू बॉन्ड्स बी फाउंड. तो कैटलिस्ट उस काम को आसान कर देता है. मतलब सिंपल सिंपल सा एग्जांपल है. मुझे तो कि एक वुड और पेपर एक ही चीज है. मतलब पेपर इज मेड आउट ऑफ वुड. किसको बर्न करना आसान है?
पेपर.
अच्छा, व्हाई इज इजी टू बर्न पेपर? क्योंकि वुड के अंदर बॉन्ड ज्यादा है, क्योंकि वुड का पीस बहुत, हाँ, क्योंकि वो इतने ज्यादा बॉन्ड्स तोड़ने. पेपर के अंदर आप पहले ही बॉन्ड्स तोड़ चुके हो. आप वो वुड को ना पीसेस में कट करके यू हैव मेड पेपर, राइट? अच्छा, फिर अच्छा, वुड के अंदर भी ना अगर वुड के पीसेस में कर दूं छोटे छोटे, फिर उसको बर्न करना आसान होगा क्योंकि मैंने पुराने बॉन्ड्स थोड़े से तोड़ दिए. डू यू गेट द आइडिया?
यस.
So this is what the catalyst does. It somehow makes it easier for the bonds to break. तो अगर आपके पास एक बहुत बड़ा वुड का पीस है ना, एक लॉग है, ठीक है, एक दरख्त है पूरा, तो दैट इज वेरी हार्ड टू बर्न. मतलब उसको आपको शुरू में बहुत एनर्जी देनी पड़ेगी, उसके नीचे आग लगानी पड़ेगी, तब जाके वो कहीं जलना शुरू होगा. बट इफ यू कैन कट इट इनटू, उसके पुराने बॉन्ड्स तोड़ दो थोड़े से, उसको श्रेड करके ना छोटे छोटे पीसेस में तोड़ दो, then burning that wood would be a lot easier because you've done some of the job. ठीक है, you've done, आपने उसकी एक्टिवेशन एनर्जी थोड़ी सी रिड्यूस कर दी है. You have gone and broken some of the bonds. So catalyst kind of does something like that. Okay, it helps you break the bonds. The number of collisions remain exactly the same. They're just now more effective. You get more effective collisions. Is this clear?
Yeah.
अच्छा, लास्ट जो था वो सरफेस एरिया क्या करता है? सरफेस एरिया सिंपली इंक्रीजेस. अच्छा, what does the surface area do? Surface area simply I mean powder का surface area ज़्यादा होता है. If there's a solid lump, तो उसका जो surface area होगा that would be lesser. Like in the powdered, in a solid, the middle ones cannot react because they're covered completely. In powdered form, they all can react. So you've got more surface area, and now if you have more surface area, then obviously you're going to have more frequent collisions. So you're going to have more frequent collisions. Is that clear?
Yes.
Achha, so first thing, be very careful. Understand why every time the reaction speeds up. Surface area, why? Because you get more surface area, you get more frequent collisions. Catalyst does not increase the number of collisions. It remains exactly the same. They just become more effective. 100 collisions, pehle catalyst ke bagayar the reaction was not happening. Now you still have 100 collisions, but now the reaction is happening because it has become easier to break bonds, the old ones. Then you've got temperature. Temperature के अंदर क्या होता है कि दोनों increase होती हैं. The number of frequency of collisions also increases, and the collisions also become more effective because they have more kinetic energy. एक तो वो ज़्यादा तेजी से travel कर रहे हैं, तो they would bump into each other a lot more. और ऊपर से वो ज़्यादा तेजी से travel कर रहे हैं, तो एक दूसरे को hit भी ज़्यादा strongly करेंगे. तो इसलिए you will get more effective collisions. एंड प्रेशर के अंदर है कि प्रेशर के अंदर यू ऑब्वियसली वॉल्यूम कम हो जाता है, करीब करीब हो जाते हैं, यू गेट दे क्लोजर टुगेदर, यू गेट मोर फ्रीक्वेंट collisions. वो ज़्यादा एक दूसरे के साथ they would bump. और concentration में कि higher concentration means and remember focus on the word concentration, ठीक है? Not volume, not mass. Concentration is something different. So concentration is you get more concentration, so the particles would be closer together and they would bump into each other a lot more, and you'll get more frequent collisions. Is this clear?
Yes.
So secondly, how do you measure speed of reaction? Speed of reaction के अंदर पहले तो बताओ कि when you do any experiment, speed is rate, right? तो इसका जल्दी से बताओ कि when you talk about speed of reaction or rate of reaction, तो इसके अंदर what do you need? What piece of apparatus do you always need? Like you're doing an experiment. How do you measure rate? Any idea? ठीक है, you would need a clock, definitely. ठीक है. So you've got so I have this reaction happening. There's MgCl2 and I've got H2 gas, right? अच्छा, first thing, rate or speed. ठीक है, Olympics में अभी races चल रही हैं, so there's you measure the speed of a runner, right? So how do you measure the speed of a runner? Speed or rate is any change that's happening with respect to time. Like it could be any change. It's not just so it's any change with respect to time. So if that change happens very quickly, it takes a small amount of time, then the reaction is very fast. If that change happens very slowly, so it could be any change. It could be a change in mass. It could be a change in volume. It could be change in color. So if the color changes very quickly, that's a fast reaction. If it changes very slowly, then it's a slow reaction. So it could be any change, any observable change. You can just time it with a stopwatch. तो 100 मीटर रेस के अंदर क्या होता है, कोई भी जाके ना मीटर्स पर सेकंड के अंदर फिजिक्स के फॉर्मूलाज नहीं यूज कर रहा होता. व्हाट दे डू इज उन्होंने एक चेंज फिक्स कर लिया कि जी वो एक 100 मीटर की लाइन है, वहां तक पहुंचना है, दैट्स द चेंज. रनर ने ना इधर से चेंज होकर उधर तक पहुंचना है, दैट्स द चेंज. दे जस्ट मेजर द टाइम, कौन जल्दी पहुंचेगा, कौन देर से पहुंचेगा. नो वन इज मेजरिंग meters per second or something, ठीक है. So it's changed with respect to time. Chemical reaction, it's obviously mass change or volume change or color change. So I have this reaction. Tell me, in how many ways can can I sort of observe the change with respect to time? One is what's changing. There's H2 gas being volume of gas being produced. So what you can do is you can collect the volume of gas, and so that's one way. Gas formed. There's a gas forming. And remember, reactions are always fast at the beginning, and then they slow down and they become constant. So why do they become constant? What does that mean? But what's happening over here? Why has H2 gas become constant?
No more H2 is being produced.
So that means the reaction has stopped, right? So reaction stopped. So there is no more H2. I said now reactions are always fast in the beginning, right? At the start, they're always fast. Uh, so the gradient shows this is the gradient and this is the gradient over here. So the gradient is the rate. Change with respect to time, the gradient is the rate. So remember this, that when you plot change with respect to time, change with respect to time, any change, whether it's volume of H2, and the change could be increasing as well as decreasing. It could be going up, it could be going down. So right, initially the reaction is very fast, and then it slows down, then it slows down, then it stops. So more gradient, or simply put, gradient is actually an indication of rate. Is this clear?
Yes.
अच्छा, and अच्छा ये भी बताओ कि why is the reaction fast at the beginning? And why? Or normally this is what happens. Reactions are always fast. Like if you're burning paper, it's going to burn very quickly at the start, and then the flames are going to die off. So you put Coke into a glass. Initially, you see a lot of bubbles, and then slowly the bubbles they become lesser and lesser, and eventually there are no bubbles. So why are reactions always faster at the beginning?
Because there are more particles.
So obviously you've got more reactants, and then they get used up. So if they get used up, there'll be lesser collisions. Like if you have right at the beginning you have more particles, and then they start reacting with each other, so the particles get used up, and there would be lesser and lesser collisions now. And a lot of reactions, they don't go to completions, क्योंकि वो कभी माचिस को भी जलाया होगा ना, तो उस पे देखा होगा कि एंड में माचिस नहीं जल रही होती. It's very hard to actually complete a reaction, क्योंकि एंड में जो particles रह जाएंगे ना, it would be very hard for them to find each other. If they can't find each other, they can't collide with each other, they can't react with each other, right? So the reaction becomes slower and slower, and it becomes harder and harder for them to collide with each other. शुरू में तो ढेर सारे थे, तो collisions आसान थी. So which is why the reaction always follows this pattern. It speeds up at the start and then starts slowing down. Acha, what else? What other way can you figure out the rate of reaction? What other change can you measure?
Mass.
ठीक है, क्योंकि H2 gas escape कर रही है, तो ये जो mass of beaker जो होगा ना, that would constantly decrease. So you can also measure the mass. Mass का उल्टा होगा. Mass का होगा कि with respect to time. शुरू में H2 gas बहुत ज़्यादा escape कर रही है, so the mass decreases very quickly, and then it slows down, and then the mass becomes constant. ठीक है, with respect to time. And again, it's the same thing. Start के अंदर the gradient is very steep, and then the gradient sort of slows down, and then eventually the reaction stops. So this is the point where the reaction completely stops. Is this clear?
Yes.
So that's about rate of reaction. So remember, it could be anything, any change. इसी reaction के अंदर you can also measure H2 gas बन रही है ना, तो you can count the bubbles. Start में bubbles ज़्यादा बन रहे होंगे, बाद में bubbles कम होंगे. So you can measure the amount of bubbles being formed, or you can measure another change that you can measure is that Mg is dissolving. So you can measure the time it takes for Mg to dissolve, how quickly that change happens. So if the reaction is very fast, then Mg would dissolve very quickly. If the reaction is very slow, then Mg would take a long time to dissolve. Is that clear?
Yes.
So just remember, speed is any change with respect to time, and when it comes to graphs, the more the gradient, the faster is the reaction. So now coming back to this, so we've gone through this very quickly. Coming back to this, it's more dilute, right? So that means slow reaction. Slow reaction means it's going to be less steep. So it's either going to be C or it's going to be D. Is that clear?
Yes.
Yeah.
So it's either going to be C or D, slower, less steep. Now, how do you figure out between C and D? अब यहाँ पे ना ये वाली बात आएगी. How many moles of sulfuric acid do you have over here?
5 into 10 power minus 3.
ठीक है, volume into concentration, right? Volume should be in dm cube. So it's 5 times 10 power minus 3
3.
moles. अच्छा, how many moles do you have over here? It's 5 cm cube or 0.5 mole per dm cube sulfuric acid, जिसके अंदर बाद में water add किया है to dilute it. But how many moles do you have? 5 into 0.5, that's
2.5 into 10 power minus 3.
अच्छा. अब सेकेंड वाले रिएक्शन के अंदर ना अगर मोल्स ही कम है, अगर आपने मोल्स ही कम लिए हैं क्योंकि आपने वॉल्यूम ही कम लिया था सल्फ्यूरिक एसिड का, तो अगर आपने मोल्स ही कम लिए तो वॉल्यूम ऑफ गैस जो बनेगी वो हाफ बनेगी ना. ऊपर वाले में मोल्स डबल है, तो जो H2 गैस बनेगी वो ज्यादा बनेगी. सेकेंड वाले में मोल्स ही कम है रिएक्टेंट्स के, तो जो प्रोडक्ट बनेंगे वो भी कम ही बनेंगे. तो दैट्स व्हाई इट्स गोइंग टू बी डी, कि एंड में जो गैस बनेगी ना H2, उसकी क्वांटिटी कम होगी. इज दिस क्लियर?
Yes.
ठीक है, तो बस इसका ख्याल रखना कि क्योंकि ये क्वेश्चन खाली वो डाइल्यूशन के ऊपर ही था. डाइल्यूशन के ऊपर होता तो फिर तो सी होता. यू ऑल्सो हैड टू कि वो वॉल्यूम कम करने से ना रेट पे कोई रेट तो कम डाइल्यूशन की वजह से हुआ था. अच्छा, अगर सेम क्वेश्चन होता और वो पानी ना ऐड करता, ठीक है, इफ इट हैड बीन एग्जैक्टली द सेम क्वेश्चन, तो the speed of the reaction would have been exactly the same, लेकिन वो में H2 गैस कम बनती. Do you get my point? क्योंकि concentration exactly same है. If he hadn't added the water. Is that clear?
Yes.
अच्छा, एक दो और कर लेते हैं, बस ये पेज कर लेते हैं. Equilibrium. Forward reaction is endothermic. Forward is endo. So that means backward is the opposite, that's exo, right? What is the effect of changing the temperature and pressure on the equilibrium position? तो temperature बढ़ाओगे कौन सा favor होगा, endo exo? What's the rule? If you increase temperature, it's always the endothermic reaction, right? So it would move to the right? अच्छा, increase pressure, less gas, more gas, कौन सी side favor होगी?
Less gas.
So when you increase pressure, तो less gas moles side is favored. तो less gas moles side ये वाली side है, क्योंकि इस side पे 2 moles of gas है, तो ये backward moves to the left होगा. So that's why it's going to be C. Is this clear?
Yes.
So next is in which reaction is the underlying compound acting as the reducing agent? But the reducing agent oxidize होता है या reduce होता है?
Oxidize.
So you're looking for the substance that gets oxidized that gains oxygen. बताओ ये oxidize हो रहा है, reduce हो रहा है?
Reduce.
ये क्या हो रहा है?
Oxidize.
बस ठीक है, फिर यही होगा. बाकी भी reduce हो रहे हैं. This is getting reduced. इसको कुछ भी नहीं हो रहा. This is not a redox reaction क्योंकि calcium is 2 plus, calcium is 2 plus, H is plus 1, Cl is minus 1, Cl is still minus 1, H is plus 1, O is minus 2. इसके अंदर nothing is happening. This is not a redox reaction. As a pair, you've got X, Y, and Z are oxides of elements in the same row of the periodic table. Some information about each oxide is shown. So, ability to neutralize an acid. अच्छा, ये alkali को neutralize कर रहा है. So is it acidic or basic? The first one.
Acidic.
ठीक है, it can only neutralize an alkali if it's acidic. तो फिर तो A ही होगा आंसर, क्योंकि अच्छा B दोनों के साथ रिएक्ट कर रहा है, सॉरी Y दोनों के साथ रिएक्ट कर रहा है. So that means it's
Amphoteric.
और ये जो है ये एसिड के साथ रिएक्ट कर रहा है, so that means it's going to be basic.
Basic.
तो वो पहले से ही पता लग गया था A है. 4 acids are dissolved in water which beaker contains, ये वो उसी का आ गया, contains the most, उसने कहा 4 acids dissolve किए हैं. वो कह रहा है which beaker contains the most concentrated strong acid solution. पहले तो strong acid आयनाइज होगा fully या नहीं होगा?
होगा।
तो इन चारों बीकर में से ये वाला जो है ना, दिस इज अ वीक एसिड, राइट? क्योंकि H और Y अभी भी इकट्ठे हैं, जबकि H और Y को अलग अलग होना चाहिए। मतलब एसिड यही होता है ना कि व्हेन यू हैव HCl इट शुड आयनाइज कंप्लीटली। वाटर में डालो तो H+1 और Cl आयन स्कैटर हो जाए, कंप्लीटली स्कैटर हो जाए। इज दिस क्लियर? आइडिया क्लियर, राइट?
यस।
So this one is a weak acid, right? And this one is also a,
वीक एसिड।
क्योंकि बहुत कम H+1 आयन्स बने हैं, मतलब वो आयनाइज ही नहीं हुआ। बहुत सारे उसी तरह जुड़े हुए हैं अभी भी। ये स्ट्रॉन्ग एसिड है क्योंकि इसमें ज्यादा H+1 आयन्स प्रोड्यूस हुए हैं, वो सारे आयनाइज हो गए। ये भी स्ट्रॉन्ग एसिड है। अच्छा, इन दोनों में से बताओ कि मुकाबला इन दोनों में से विच वन इज मोर
ए।
कॉन्सेंट्रेटेड?
ए।
ठीक है, A is more concentrated. The following substances can react together to prepare salts. The substances can be reacted together to prepare salts, right? So you've got copper 2 oxide and excess hydrochloric acid, right? अच्छा, ये salt preparation बारी बारी कर लेते हैं। Copper oxide वो रिवाइज भी कर लेते हैं। Copper oxide plus hydrochloric acid and it produces copper chloride plus water, right? Base plus acid reaction है। अच्छा, चार रिएक्शंस होते हैं जिससे सॉल्ट बनती है। वन इज मेटल प्लस एसिड, वन इज बेस प्लस एसिड, द थर्ड one is carbonate plus acid, and the fourth one is ammonia plus acid to form an ammonium salt. अब मुझे बताओ कि how do you figure out the method? Copper oxide is insoluble, it's solid. ये aqueous है, this is soluble, and this is a liquid. अब मुझे बताओ कि which method of preparation would you use?
एक्सेस।
ठीक है, soluble salts from an insoluble reactant are always produced from an excess method, जिसके अंदर you have to add this in excess. मतलब आप बीकर के अंदर HCl लोगे, राइट? और उसके अंदर यू ऐड एक्सेस कॉपर ऑक्साइड। वो एक्सेस इसलिए ऐड करना है ताकि सारा का सारा HCl रिएक्ट कर जाए एंड इट गेट्स कन्वर्टेड टू सॉल्ट एंड वाटर। और कॉपर ऑक्साइड को यू कैन जस्ट फिल्टर इट आउट क्योंकि वो सॉलिड है, इट्स इनसॉल्युबल एंड यू कैन सिंपली फिल्टर इट आउट। तो ये एक्सेस मेथड है। तो इसलिए तो इसमें हमेशा इनसॉल्युबल को एक्सेस में लेते हैं। इसने क्या गलत किया हुआ है?
कॉपर टू ऑक्साइड को एक्सेस में लेना था।
तो इसे गलत लिया हुआ है। दिस शुड हैव बीन एक्सेस। क्योंकि मसला ये कि अगर हाइड्रोक्लोरिक एसिड अगर बच जाएगा ना, तो वो फिर आप सॉल्ट से सेपरेट नहीं कर सकते क्योंकि वो भी सोल्यूशन में है और हाइड्रोक्लोरिक एसिड भी सोल्यूशन के अंदर है। सो द रीजन यू ऐड मोर कॉपर ऑक्साइड इज ताकि ऑल ऑफ द हाइड्रोक्लोरिक एसिड रिएक्ट्स। क्योंकि जब आपकी सॉल्ट प्रोड्यूस होगी ना सोल्यूशन में, इट्स सॉलेबल, तो उसके अंदर एसिड बीच में नहीं पड़ा होना चाहिए क्योंकि वो फिर अलग किस तरह करोगे, दोनों ही सॉलेबल है। सो यू कांट सेपरेट टू सॉलेबल सब्सटेंसेस। तो इसलिए इन विच रिएक्शन कैन द एक्सेस रिएक्शन बी सेपरेटेड फ्रॉम द सॉल्यूशन बाय फिल्ट्रेशन? यू कांट डू इट इन द फर्स्ट वन। इज दैट क्लियर?
यस।
अच्छा, सेकंड वाले में भी नहीं कर सकते क्योंकि सेकंड वाला जो है उसमें सारे सॉलेबल, अगर सारे सॉलेबल होते हैं, दिस इज अगेन एसिड प्लस बेस रिएक्शन, तो कौन सा मेथड यूज करते हैं इफ ऑल ऑफ देम आर सॉलेबल?
न्यूट्रलाइजेशन रिएक्शन।
ठीक है, नहीं, द मेथड इज टाइट्रेशन।
हाइड्रेशन।
ठीक है, जब सारे सॉलेबल होते हैं यू यूज टाइट्रेशन क्योंकि उसके अंदर
Sir,
मसला ये है
when to
कि
use precipitation reaction?
वो होता है जब सॉल्ट इनसॉलेबल हो।
Okay.
ठीक है, उस पे वो मैं आता हूँ, इसमें तो नहीं है लेकिन वो मैं अलग से एक्सप्लेन कर देता हूँ। ठीक है, जब सारे सॉलेबल होते हैं ना तो इट्स टाइट्रेशन। क्योंकि इसमें मसला ये कि अगर NaOH ज़्यादा डाल दिया ना, बच गया NaOH, तो NaCl भी सोल्यूशन के अंदर है, NaOH भी सोल्यूशन में अलग कर ही नहीं सकते। HCl अगर ज़्यादा डाल दिया तो NaCl जब बनेगा तो उसमें बचा हुआ HCl पड़ा होगा तो उसको भी सेपरेट नहीं कर सकते, राइट? तो इसके अंदर तो सेपरेशन पॉसिबल ही नहीं है। इसके अंदर टाइट्रेशन इसीलिए करते हैं ताकि वो इंडिकेटर आपको बता दे एग्जैक्टली कि दोनों एग्जैक्ट इक्वल क्वांटिटी में रिएक्ट कर जाए, कुछ भी ना बचे, एक्स्ट्रा कुछ भी ना हो। वो इंडिकेटर फॉरन कलर चेंज कर देगा। क्लियर है बात?
Yes, sir.
यस।
तो इसके अंदर तो आप फिल्टर कर ही नहीं सकते क्योंकि सारे ही सॉलेबल हैं। तो यू कांट फिल्ट्रेशन तो काम ही नहीं करेगी इसमें, कि जब आपके पास NaCl बनेगा ना और वो पीछे रिएक्टेंट बच गया ना, तो वो तो कभी भी आप सेपरेट नहीं कर सकते। तो इसलिए उसके अंदर आप टाइट्रेशन करते हो। अच्छा, थर्ड वन सही है, जिंक कार्बोनेट।
Right.
इट्स अ कार्बोनेट प्लस एसिड। तो आंसर 3 ओनली होगा वैसे। तो उसके अंदर आप जिंक क्या बनेगा, क्लोराइड प्लस वाटर प्लस कार्बन डाइऑक्साइड, राइट? सो जिंक कार्बोनेट इज अ सॉलिड, एक्वस। ये भी एक्वस है, सॉलेबल है, ठीक है। रिमेंबर द सॉलिबिलिटी टेबल, लिक्विड और गैस। अच्छा, थर्ड वन के अंदर इसको अगर आप एक्सेस में लोगे ना तो काम चल जाएगा। HCl सारा का सारा रिएक्ट कर जाएगा, जिंक क्लोराइड बनेगा सोल्यूशन के अंदर, और उसके अंदर जो बचा हुआ जिंक कार्बोनेट पड़ा हुआ भी होगा ना, इट्स सॉलिड, यू कैन फिल्टर इट आउट।
So
तो
this is also an excess reaction, right?
हाँ, मतलब इसके अंदर आप एक्सेस मेथड
Okay.
ही यूज करोगे। मतलब इसके अंदर भी आपने एक्सेस मेथड यूज करना था, लेकिन उसने गलत वाले को एक्सेस में कहा हुआ था। क्लियर है?
Yeah.
मतलब इसमें इसमें भी ना अपने हमेशा सॉलिड रिएक्टेंट को एक्सेस में रखते हैं, ठीक है। तो रिमेंबर आपके पास 4 रिएक्शंस है, मेटल प्लस एसिड, बेस प्लस एसिड, कार्बोनेट प्लस एसिड और अमोनिया प्लस एसिड। अगर तो चारों में से कोई भी रिएक्शन हो, सॉल्ट सॉलेबल हो और रिएक्टेंट इनसॉलेबल हो, तो आप एक्सेस मेथड यूज करोगे, और सॉलिड वाले को ना आप एक्सेस में रखोगे। वेदर इट्स ये बेस प्लस एसिड है, ये कार्बोनेट प्लस एसिड है, जो मर्जी रिएक्शन है, डजंट रियली मैटर। दोनों पे एक्सेस मेथड अप्लाई होगा, बस सॉलिड वाले को एक्सेस में रखना है, इसलिए वो फर्स्ट वाला गलत था, ठीक है। थर्ड वाला ठीक है। और तीसरा है आयनिक प्रेसिपिटेशन, जो कि इसमें तो मेंशन नहीं है, लेकिन आई जस्ट डू इट सेपरेटली के व्हाट इज आयनिक प्रेसिपिटेशन व्हेन यू ट्राई टू मेक एन इनसॉल्युबल सॉल्ट लाइक कैल्शियम कार्बोनेट। तो उसका ना उन चारों रिएक्शन से कोई ताल्लुक नहीं है। कैल्शियम कार्बोनेट बनाना है ना, तो insoluble salt, remember insoluble salt is always going to be made from ionic precipitation। नहीं, मुस्तफ़ा, ये टाइट्रेशन का याद रखो कि टाइट्रेशन ये मैंने मेरे ख्याल से पहले भी इसी बोर्ड पे एक्सप्लेन किया था। एक सेकेंड, मैं फिर से एक्सप्लेन कर रहा हूँ। मतलब इसमें मैंने चौथा रिएक्शन लिखा है, इसमें नहीं एक्सेस लिखा हुआ था। अच्छा सॉरी, अच्छा, remember titration could be applied to any reaction, ये base plus acid, carbonate plus acid, uh, ammonia plus acid, ठीक है। और as long as the reactants are all soluble and the salt that's produced is also soluble, तो वो जरूरी नहीं है वो किसी एक रिएक्शन के ऊपर टाइट्रेशन नहीं अप्लाई होती, इनमें से किसी रिएक्शन के ऊपर भी टाइट्रेशन अप्लाई हो सकती है, as long as सारे soluble हो। मुस्तफा, is this clear? मतलब जो आपने लिखा है ना अल्कली वाला, उसके ऊपर भी टाइट्रेशन अप्लाई होगी एज लॉन्ग एज ऑल ऑफ देम आर सॉल्युबल, ठीक है। मतलब एक एग्जांपल मैं दे देता हूँ कि इधर ही मैं दे देता हूँ, और सारे अल्कली वाले रिएक्शन पे भी नहीं अप्लाई होती टाइट्रेशन, कि अगर ना मैं लूँ अल्कली बैरियम हाइड्रोक्साइड, दैट्स अ सॉल्युबल बेस इज एन अल्कली, राइट, और मैं साथ लूँ H2SO4, तो वो भी सॉल्युबल है, लेकिन वो मिलके बनाते हैं बैरियम सल्फेट, एंड बैरियम सल्फेट इज अ सॉलिड, वो इनसॉल्युबल है। तो यहाँ पे यू कांट रियली अप्लाई टाइट्रेशन, इसके अंदर टाइट्रेशन अप्लाई नहीं होगी, ठीक है। ये
So
आयनिक
all
प्रेसिपिटेशन
hydroxides are soluble.
नहीं, वो तो सॉल्युबिलिटी टेबल यूज करना है उसमें ना। यहाँ पे ये शीट आप लोग ले लो, ये मैं उसके ऊपर पोस्ट भी कर देता हूँ, जस्ट अ सेकेंड। उसके अंदर ना सारी चीज़ें लिखी होंगी जो चाहिए, जस्ट 1 सेकेंड। अच्छा, एक ये एसिड बेसिस सॉल्ट्स ओनली की शीट है, अगर ये ओपन हो जाए, ठीक है, ये मैं सेंड कर दूंगा, मैं इधर वैसे एक्सप्लेन कर रहा हूँ, ठीक है। ये फॉर्मूलाज हैं आयंस के, ये फॉर्मूला है एसिड्स के। अच्छा, ये सॉल्युबिलिटी टेबल लिखा हुआ है, नॉट ऑल, यहाँ पे ऑक्साइड्स और हाइड्रोक्साइड्स का लिखा हुआ है कि बेसिस होते हैं, ठीक है। Now, not all of them are soluble. You've got group 1, NH4 plus 1. इनके group 1 के hydroxides, oxides soluble होते हैं। NH4 plus 1 का soluble होता है, NH4OH हो गया, ठीक है, that's soluble। और थोड़े से ना lower down in group 2, जैसा barium hydroxide या strontium hydroxide। इसके अलावा बाकी सारे insoluble है। Is that clear?
Yes.
मतलब कॉपर हाइड्रोक्साइड होगा तो वो insoluble होगा, आयरन हाइड्रोक्साइड होगा that's insoluble। तो इसके अंदर सारा दिया हुआ है, और फिर इसके अंदर वो दिया हुआ भी है कि इन सारे तरीकों से ना सॉल्ट प्रोड्यूस होती है। बस ये जो लास्ट वाला रिएक्शन है ना, ये सॉल्ट प्रिपरेशन में यूज नहीं होता। एसिड प्लस बेस, एसिड प्लस कार्बोनेट, एसिड प्लस मेटल या एसिड प्लस अमोनिया, इन चारों तरीकों से ना सॉल्ट प्रोड्यूस होती है। और इसमें वो भी लिखा हुआ है कि कौन से मेथड है वो यहाँ पे। टाइट्रेशन कब यूज करनी है? जब सारे सॉल्युबल हो इक्वेशन में। आयनिक प्रेसिपिटेशन कब यूज करनी है? जब रिएक्टेंट सॉल्युबल हो और प्रोडक्ट जो है वो इनसॉल्युबल हो, यानी सॉल्ट इनसॉल्युबल हो। और एक्सेस मेथड कब यूज करना है? जब रिएक्टेंट इनसॉल्युबल हो और सॉल्ट जो है ना वो सॉल्युबल हो। ये वैसे गलत लिखा हुआ है, इसको करेक्ट करना है। ये नोट कर लेना, मैं ये वाला पार्ट गलत है। बस ये सॉल्युबल होना मस्ट है, ठीक है। अच्छा, एनीवेज, तो आयनिक प्रेसिपिटेशन की मैं एक एग्जांपल करा रहा था कि अगर आई वांट टू मेक एनी इनसॉल्युबल थिंग, PbSO4, तो उसके अंदर आयनिक प्रेसिपिटेशन करनी है। उसका उन रिएक्शन से कोई ताल्लुक नहीं है। उसके अंदर आप सिंपली क्या करोगे कि थिंक ऑफ अ सब्सटेंस दैट कंटेन्स Pb एंड थिंक ऑफ अ सब्सटेंस दैट कंटेन्स SO4। शर्त यह है कि दोनों सब्सटेंसेस जो है ना वो सॉल्युबल होने चाहिए। तो मैं लेड नाइट्रेट कर लेता हूँ, क्योंकि लेड नाइट्रेट सारे के सारे सॉल्युबल होते हैं। और थिंक ऑफ अ सब्सटेंस दैट कंटेन्स सल्फेट एंड इट्स सॉल्युबल, तो वो H2SO4 भी हो सकता है, Na2SO4 ग्रुप 1 के सॉल्युबल हो सकते हैं, ठीक है। ऑल ऑफ देम कैन बी सॉल्युबल, राइट। तो इन दोनों को मैं मिक्स करूंगा। जब वो सॉल्युबल होते हैं ना, तो व्हाट हैपेंस इज के देयर आयंस दे कंप्लीटली गेट स्कैटर्ड इन वाटर, दे डिसोसिएट। तो लेड आयंस अलग घूम रहे होंगे क्योंकि वो सॉल्युबल है, नाइट्रेट आयंस अलग घूम रहे होंगे पानी के अंदर, ठीक है। Na2SO4 भी सॉल्युबल है, तो सोडियम आयंस और सल्फेट आयंस सारे अलग अलग घूम रहे होंगे। जब दोनों को मिक्स करोगे ना, तो दे वुड स्टार्ट कंबाइनिंग, Pb एंड SO4 वुड कंबाइन एंड दे वुड फॉर्म अ सॉलिड प्रेसिपिटेट, क्योंकि वो तो इनसॉल्युबल है। तो PbSO4 जो है ना वो सॉलिड बन के ना बाहर निकल जाएगा सोल्यूशन से। Na और NO3 कंबाइन भी कर जाए ना, तो NaNO3 इज सॉल्युबल, सो इट वुड रिमेन पार्ट ऑफ द सोल्यूशन। तो वो पानी के अंदर ही घूमते रहेंगे। इज दिस क्लियर?
Yes.
Yes, sir.
तो बस इसका याद रखना कि सॉल्ट प्रिपरेशन, ठीक है, फिर से मैं रिवाइज कर रहा हूँ कि सॉल्ट प्रिपरेशन के अंदर you've got बल्कि उस शीट के ऊपर रिवाइज कर देता हूँ। अपार्ट फ्रॉम आयनिक प्रेसिपिटेशन, सॉल्ट प्रिपरेशन में ये चार रिएक्शंस है, पहले पहले चार रिएक्शंस, ठीक है। और उसके अंदर मेथड कौन सा यूज होना है, दैट इज डिपेंडेंट ऑन द सॉल्युबिलिटीज। सारे सॉल्युबल टाइट्रेशन, प्रेसिपिटेशन अगर इनसॉल्युबल सॉल्ट हो, और एक्सेस मेथड अगर रिएक्टेंट इनसॉल्युबल हो, तो ये करना है। चलो ठीक है, मैं इसकी ना एक वो डिटेल लेक्चर भी सेंड कर दूंगा इसका, सॉल्ट्स वगैरह का, ठीक है, वीडियो लेक्चर। प्लस मैं ये शीट भी ना आपको भेज दूंगा। शीट में थोड़ी सी गलती है, मैं ज़रा गौर से देख लूँ। इसमें डीकॉम्पोजिशन रिएक्शन भी गलत है। हाँ, ये डीकॉम्पोजिशन रिएक्शंस का भी ख्याल रखना कि ये दो एक्चुअली सही लग रहे हैं, मुझे तो सही लग रहे हैं। नहीं, ठीक है। मेटल नाइट्रेट ठीक है, सही है। और इसके अंदर वो फिर सारे वो सॉल्ट्स के कलर्स वगैरह वो याद रखने हैं, प्लस ये टेस्ट वगैरह याद रखने हैं। सो आई विल बी सेंडिंग द शीट इन द ग्रुप। बस यहाँ से फिर कल कंटिन्यू करते हैं, ठीक है। ओके देन,
Love it.
ठीक है, अल्लाह
Love
हाफिज़।
it, sir.
अल्लाह हाफिज़।